Hi guys, Mr. Gucci here with your third midterm review video in which we go over Unit 3, the elements. Not many multiple choices here because the real focus was on the free response. So the first part is, let's fill out this chart here, all right, in which I give you either the atomic symbol or element name or protons, neutrons, and electrons, and you have to fill in the blank spots. Quick point. I screwed up number 7. I should have put the word gold here. I needed to give you the element name in order to solve this. So if you couldn't solve number 7, my bad. Just do it assuming that the element was gold. All right, so let's get to it. So first off, number 4. This element, S, if we look at the periodic table, we see is sulfur. How many protons does it have? Well, two ways to figure that out. Sulfur is element 16 on the periodic table, or you see the 16 right down here. That is the atomic number. It has 16 protons, all right? How many neutrons does it have? Well, it has a mass of 33. Why do that? It has a mass of 33 AMU, and that's equal to its protons plus its neutrons. So protons plus neutrons equals 33. We know that there are 16 protons, so 16 plus neutrons equals 33. 16 plus what is 33? The answer is, using a bit of subtraction, 17. There are 17 neutrons. Lastly, how many electrons does this have? Well, it has a charge of 2 minus. That means that it has 2 more electrons than it does protons. A negative charge means it has that many more electrons. So because it is a 2 minus charge, it's got 2 more electrons than it does protons. It's got 16 protons, so 2 more than that is 18. All right, on to the next one, number 5. So as always, we're going to start with the protons here. This is 45 protons, which means element 45. So what is element 45? Well, I go to this virtual periodic table. It is rhodium. All right, rhodium. You might not have heard of it, but this is what's coating white gold jewelry to give it that white shine. Real white gold actually has kind of a yellowish tinge, and so they coat it in rhodium to give it a beautiful white gleam that we know as white gold. It's not actually the gold you're seeing, it's the rhodium. Anyways, element 45, the symbol is RH. So, RH. Okay. It has 45 protons, so that is atomic number 45. It has 52 neutrons, so 45 protons and 52 neutrons, add them together, and we get a mass of 97. The charge, it has 43 electrons and 45 protons. That means 2 more protons than it does electrons. That means it's going to have a positive 2 charge. All right, so these were 2 of the easier ones, going from symbol to charge, or symbol to subatomic particles, or going from subatomic particles to symbol. Now let's do chlorine, Cl. Chlorine. We need to figure out how many protons it has, and that's as easy as finding chlorine on the periodic table. Chlorine is element 17. So this has 17 protons. And from here, we're off to the races. 17 protons, 18 electrons. That means it has 1 more electron, so it's got a 1 minus charge. It's got 17 protons and a total mass of 35. So 17 plus what equals 35? That's your neutrons. And the answer is 17 plus 18 gives us 35. So that's 17 protons, 18 neutrons. Lastly, let's do this final one. And again, we're going to assume it was gold. You need either the protons, the element name, or the symbol to solve this. So let's get to it. Gold is, on the periodic table, element 79. 79. So we see here 79 protons, 79 electrons. That means it doesn't have any charge at all. So we can delete the charge. The symbol for gold is AU, is one of the weird ones. 79 protons. And 121 neutrons, protons plus neutrons. 79 plus 121 is equal to 200. So there we go. That's the last symbol. All right? Down here. Now you'll notice when we were counting the mass, i.e. that number in the upper left, we weren't including electrons as part of it. Why not? Well, simple. Electrons are much smaller than protons or neutrons. All right? Protons and neutrons are 1 AMU. Electrons are 1/1800th, almost 1/2000th of the size. You would need 1,800 electrons to equal a single proton or neutron. So why don't we add it to the mass? It doesn't matter. It's too small to matter. The same reason why when you're trying to lose weight, you don't bother cutting your fingernails extra close. Will you lose a little weight? Yeah, but not a measurable amount. All right? If you know the name of the element, what subatomic particle can you be certain about? You can know the protons. All right? If you know the name, then find it on the periodic table. Its atomic number is equal to the number. Oh, thank you for filling that out for me, Google. You're so smart. Except I messed that up. So there you go. If you know the name, look it up on the periodic table, and you can find its atomic number. And that is how many protons it has, all right? We literally count elements up on the periodic table by their number of protons. Next up, what is the atomic mass of an element with the following isotopes, all right? Isotope 1 has 23 protons, 25 neutrons, and is 65.4% abundant, yada, 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 yada. So, to find the atomic mass, the weighted average, you need the mass of all these isotopes times their percent. Now, I was a bit of a tricky dick here. I didn't give you directly the atomic mass, but I gave you the protons and the neutrons. So add them together. 23 protons and 25 neutrons is equal to 48 AMU times 65.4%. All right? What is that equal to? I'll plug it into the calculator and see. 31.392. 31.392. Paste that for me. 31.392 AMU. All right, amusement park. What the hell? All right, on to the next one. All right, here we go. 23 plus 27 is 50 AMU. And it's 30.7% abundant. 30.7%. So 50 times 30.7 is what? I don't want to guess. 15.35 AMU. All right. Paste without formatting. 15.35 AMU. All right. Lastly, we have got 23 protons and 28 neutrons. 23 plus 28 is a 51 AMU. It is 4.9% abundant. So 51 times 4.9 is what? 2.5? 2.499 AMU. All right. So we're almost there. The atomic mass then is to add all of these numbers up together. All right, here we go. So 30.1 plus 15.35 plus 2.499. Now, before I press enter, I want to check myself here. I know that my answer needs to be somewhere between the low and the high number. So it must be between 48 and 51 and closer to whatever I have more of. So I have very little of the 51 and about 2/3 of the 48 isotope. So my answer should be closer to 48 than 51. Let's take a looky-loo. Yeah, 49.2. 49.2 AMU. All right, so to find the atomic mass, you take the mass of each isotope times its percent abundance, and then you add those answers all together. All right, there you go. Next up, number 11 was Dmitry Mendeleev's. What was Dmitry Mendeleev's innovation when designing the periodic table? Simple, folks. Simple. All right. Dmitry Mendeleev left gaps for elements that had not yet been discovered. And when he left those gaps, the periodic table aligned into a pattern that holds true to this day. All right. Henry Moseley discovered that elements count up by number of protons. All right, elements count up by the number of protons. It's not counting up by mass. Every element is the next step up in number of protons. All right, this found all the gaps in the periodic table since we knew that there had to be an element for every number of protons that were available. All right, lastly, you have to fill in the blank right here using the periodic table. All right, the halogen in period 3. So period 3 is right here, and the halogens are the second to last column, so that would be chlorine. All right, chlorine. Let's highlight that. There we go. Cool. All right. The alkaline earth metal in period 5. So the alkaline earth metal is the second column, and period 5 would be, there we go, strontium, element 38. So, strontium. All right. The noble gas in period 6. I think you know the noble gases are the ones at the very end. So the noble gas in period 6 is radon. Radon. You have detectors in your basement for radon. It's not chemically reactive, but is radioactive and will give you lung cancer. All right? So don't want that in your house. The element in group 7, period 5. So group 7, 1, 2, 3, 4, 5, 6, 7. So everything in manganese, all right? And period 5, technetium. TC, technetium. Famously, the smallest radioactive element, highly unstable. All right, the transition metal with the fewest protons. So we look here, everything in that maroon is the transition metals, and the smallest one is scandium, element number 21. Scandium, did I get that right? Scandium. There you go. All right, guys, I hope this video was a help.